So welcome to part 2 of 5 of NIEM Advanced Technical Concepts. Now this presentation isn't really about NIEM technical concepts, it's really about the XML things you need to know in order to later understand the NIEM Advanced Technical Concepts. So we're going to talk about two main areas here. First we're going to talk basic XML concepts, how does XML work? And then we're going to talk about basic XML schema, how does XML schema work? And frankly, unless you understand these two things, very little in the NIEM is going to make any sense to you at all. So this is, while it's not all that NIEM specific, it's important stuff, and you really need to cover it. So let me start off in learning XML with a quick caveat. What we're going to do here is a quick overview. It's not an in-depth treatment of how XML works. It's a quick overview. So if you don't have any experience with XML, please pause right now and go take an online course. There are a bazillion online courses available for learning XML. But don't just take any old XML course. Look for one that actually covers XML schema, because a lot of them don't. A lot of them spend a lot of time on basic XML stuff, and then they gloss over XML schema in about 5 seconds, and that's not going to be enough. XML schema's not easy to understand your first time through it. So please go find an XML course. Now, if you already know XML pretty well, you'll still want to go through this presentation as a quick refresher and overview. But again, please, if you have no experience with XML at all, pause this video and go take an online course. I can give you an overview, but it's not going to be rigorous enough for you to really grasp what happens with the NIEM later on. So if you don't know any XML, if you're brand new at XML, do yourself a favor and go take an XML course first. Now you've seen this slide before. It lists the various things that the NIEM naming and design rules of the NDR covers. And you'll see that very first bullet. The reason I'm showing you the slide again is primarily for that very first bullet. The NDR tells you how to use XML schema in the context of the NIEM. If you don't know XML schema, then the NDR's advice and requirements on how to use XML schema in the NIEM are going to be little or no use. You'll need to understand XML schema first to understand how the NIEM works and to have a clue at what the naming and design rules are talking about. Also, take a look at the second to last bullet on extending the NIEM. Again, the way you extend the NIEM is by making new elements and types in XML schema. So again, XML schema is required for being able to extend the NIEM. And frankly, you can't use the NIEM very well without extending it. So again, this is just here to show you XML and XML schema are kind of the bedrock foundation for how the NIEM currently works. And you need to know how those work in order to use the NIEM. So let's start our quick overview of XML with a simple question. What in the world is XML? Well, XML is a method of tagging information. It's a way of putting tags around things that describe what those things it surrounds are. You may be a little bit familiar with it by looking at the source for web pages, which uses HTML, these days often XML compliant HTML, but in the old days it was a kind of haphazard version of XML. What's nice about XML is it's very easy to distinguish the tags from the information itself. It's particularly easy for computers to do this in a rigorous way. But XML is also human readable in that you can eyeball XML, see where the tags are, see what they surround, and get a clue as to what's going on. So XML is great for computers to handle, but it's also reasonable for human beings to handle, and that gives it a lot of its power. It's also based on plain old text. XML isn't a binary format, it's a textual format. You can write XML in a plain vanilla text editor if that's what you want. You can fairly easily generate XML in a variety of different programming languages and on a variety of different platforms. So XML is kind of ubiquitous. It's everywhere. Pretty much every platform supports it. Pretty much any programming development environment supports it. So the bottom line is you can create XML just about on anything. You can consume XML on just about anything, which allows for the sharing of information between incompatible platforms. You don't have to be on the same platform as your Exchange partner because XML really doesn't care. It's independent of that. And regardless of what you're working on, if it's anything better than, say, a Commodore 64, pretty much anything you're working on can handle XML. so that's part of its power. XML is really everywhere these days. It's a very popular technology. So I talked a little bit about how XML uses tags around chunks of information to tell you what that information actually is. And well, let's work from the ground up. And let's first talk about what the requirements are for tag names. It's a little weird because there's a lot of little rules, but it gives you a place to start. Tag names can contain letters, numbers, and a few other certain characters. In general, don't use those other characters. You can use underscores and dashes, and that's okay. But in general, stick to letters and maybe numbers. Tag names cannot start with a number or punctuation, however. They have to start with letters. So basically, stick to letters. They must not start with XML, XML all uppercase, XML with an initial capital X, or indeed any other capitalization combination of the letters X, M, and L. Now, why? Well, that's a rule that's there in case XML ever decides to have special tags starting with XML. Currently, it doesn't, and in fact, a lot of XML tools will let you start your tags with these forbidden letters, but you really shouldn't. The specification for XML says not to, so don't. And then finally, the tag names must not contain spaces. XML uses spaces to delimit a lot of things, and the tag names themselves cannot contain spaces. They have to be all text. But you can use capitalization within the tag names to help delineate different words. For example, if I have a tag name person name, I can capitalize the P and the N and basically have it be readable as the two words person name while still being just one string of characters. So, ta-da! Here is our first glimpse at some actual XML. Now you'll see two columns here. The column on the left contains valid XML tag names, and they're inside angle brackets. That's how XML basically brackets tag names, puts angle brackets around them. And you'll see the ones on the left are all valid. You see my suggestion from the previous slide, person name with a capital P and a capital N. That's called camel casing because it forms little humps like a camel to perform a tag called person name. But you also see person name with an underscore in between. You see person 123, that's valid. Person with a dash name, that's valid. Or person with a dot in a name, that's valid as well, although it's not recommended that in general you use periods inside of tag names. But it is valid, you can do it. In the right column, you'll see a bunch of names that are invalid. The first one is person underscore name with an ampersand on the end, and ampersands are one of the non-allowed characters. You can't have that in the name. The second example, 123 with then the underscore, well, that doesn't start with a character, it starts with a number. That's invalid. The third one has a space in the middle of it. Oh, that's invalid too, because you can't have spaces. They have to be lumped together as person name, all one string. The fourth one is tricky, and depending on the font you're looking at these things in, can actually be hard to find. There's a space in front of the word person name, and indeed XML doesn't allow a space there. It's kind of cool about a space at the end. It won't complain too much about that, but you can't have a space between the beginning of the name and that opening angle bracket. So that one's invalid too. But again, that's sometimes hard to see depending on the font you're using. And then the last example there sticks a semicolon in between person and name. And that's invalid as well because a semicolon is another one of those special characters that's not allowed in tag names. So the bottom line here is stick to characters. You can use numbers if the numbers actually add specific meaning that only the numbers would, but they can't start the tag name. And you can use underscores and dashes if you want to separate words out, but in general people use camel casing to do that. And no spaces in the names. A few final considerations about naming tags before we actually start looking at chunks of real XML. Number one, your tag name should be descriptive. Yeah, you can make a tag name called ABCDEF. GEHI, you can do that, but it's not descriptive of anything. They really should be descriptive of the kind of information they're going to hold. From the previous slide, we saw person name used. You see that as a tag. You can be pretty assured that what's going to come in between the tags is a person's name. When it's ABCDEFG, that doesn't tell you anything at all. You can make tag names pretty much as long as you want. There really isn't a defined maximum length. Now, if you make them too long, you'll end up with errors somewhere on some systems. So make them long enough to accomplish the need to be descriptive, but don't get carried away. Don't make it A, B, C, D, E, F, G, H, I, da, 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 da. Don't make it the quick brown fox jumped over the lazy dog. Don't make it a short story. Just don't make it horribly long. Long enough to be descriptive, but no longer. Avoid the dash, period, and colon. They're allowed, but you may end up regretting it. The dash can cause problems, periods can cause problems, and colons are used for namespaces, which we'll talk about much later, and they can cause problems as well. So these things are all allowed, but you may regret it later on when you find problems with some systems that can't handle them. Although, again, technically they're allowed. Non-English letters are also supported. Just some examples, with the different accents, different ways. If you speak Hungarian, you're aware of Hungarian's vast array of different letters with different accents and double accents and dots and double dots that provide a very, 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 very rich alphabet to use. And those things are legal. They're legal in XML. But there is a drawback in that, again, you may run into systems that, although those letters are legal, the system may not be able to handle it. So in general, unless you really have a pressing need to use some sort of accented character, in general I would avoid them just to be safe. They may not be supported on all platforms. So here we see some real actual XML. Now there's three things I want you to note about this. First of all, you'll see that there are tags, and we can identify the tags because they have angle brackets starting and ending each tag. And the tag names inside follow the rules we talked about in the previous slides. In this case, we're using basically strings of characters and using camel casing to break apart the different names, or the different pieces of the name, so that you can see that it's person name, not personami or something like that. So that's number one. These tags have names. The second thing I want you to notice is that there are opening and closing tags. You'll see at the very beginning is a person tag, and at the very end, there's an identical tag except for it has a slash in it. That slash identifies that as the closing tag. And everything in between the person tag and the closing person tag are things that are inside the person tags. So each set of tags comes as a pair, an opening tag and a closing tag. The closing tag is the same as the opening tag except for it has a slash in it. And so that's the second thing. The third thing you need to notice here is that a hierarchy is formed. We have the person tags on the outside, and in XML that's called the root element. That's the outermost set of tags. Inside of that are a pair of person name tags, an opening and a closing tag. So that makes the person name tag a child of the person tag. So we're forming a hierarchy. Inside of the person name tag, we see the pair for person given name. There's an opening person given name tag, and then there's a closing person given name tag. And then inside of that is an actual chunk of data, a name. So person given name, Tom, happens to be mine. So the person given name is a child of person name. Now the relationship works in reverse as well. We can talk about person being the parent of person name and person name being the parent of person given name. So you can look at the hierarchy in either direction. Either person's the parent of person name or person name is the child of person. Either way.